Welcome to Sources classes. Today we are going to be dealing with optimization with Kuhn sufficiency theorem. Let's start off with a simple sum. Over here we are given a minimization problem. Notice since the questions are not visible, I have written it on the right side of the screen. It's given minimize c equals to fx subjected to the constraint g to power ix greater than equals to ri, where I goes from 1 to m and x is greater than 0. We need to convert it into a maximization problem. The process is very simple. We first write maximize, then we multiply -1 to this function on both sides, which results into minus c equals to minus fx. Now we do the same for the constraints that are given, that is minus g to power I x less than equals to ri, where I goes from 1 to till m. Notice the inequality has changed since we have multiplied a negative number on both sides of this equation. For x, however, the only change is the equality sign. This is because x is the input variable in this problem. Next we see what question number B has to offer. We have to find out whether the present problem are the equivalents of the f and g to power I functions in the Kuhn sufficiency theorem. Notice here small letter f and g to power I are given, signifying a different function. That is fx equals to minus fx, g to power ix equals to minus g to power I x. This is the condition that has been asked in question number B. Now we move on to question number C. Please read the question because you might not be able to follow me. In this question, however, I will explain that what concavity and convexity conditions should be placed on f and g to power I. Since you can question the entire thing, I am making it clear out here. We have to find the sufficient conditions for a maximum applicable here. For that, we need fx should be convex and g to power ix should be concave, that is in the non-negative orthant. Oh my god. In geometry, an orthant or a hyperoctant is the analog in n-dimensional Euclidean space of a quadrant in a plane or an octant in a 3-dimensional figure. Over here we are given with a minimization problem, that is minimize c equals to fx subjected to g to power ix greater than equals to ri and x greater than equals to 0. Now we need to state the Kuhn sufficient condition for a minimum. Let first one be f is differentiable and convex in the non-negative orthant, that which I explained in the previous question. Now the second conditions that is required, that each g to power I is differentiable and concave in the same non-negative orthant. And lastly, we will see that the point x star satisfies the kt minimum conditions. KT over here means Kuhn-Tucker. I have written it in short, you can always write it in full sentences. Then after that we have to write if X star gives a global minimum of C. And there you have it. This is a sample of how we write Kuhn-Tucker conditions for optimization problems. In a future video, we will be doing further sums on various such topics. Stay tuned. Please like, subscribe and comment on this video.